Ladies and gentlemen, first of all, I'd like to thank the organizers for inviting me and giving me the opportunity to speak about the research and development work we do in thin film solar cells. So as I'm introduced, actually I have three hats or three capacities or part of personality. I'm a scientist. I studied in IIT Delhi. I was born and brought up, of course, in India. And then I moved to ETH, which is Swiss Federal Institute of Technology, very well known from where Albert Einstein did his education. And there I started doing research in thin film solar cells. And after that, I also became a professor. And I founded a company, FLISM, which starts for flexible, lightweight solar cells. So I have been able to manage doing fundamental research, applied industry-oriented research at EMPA, which is Swiss Federal Laboratories for Material Science and Technology, something similar to National Physical Lab in India. And the FLISM company is a startup company from my research group. So basically, I'll be talking about high performance, lightweight, flexible solar modules, which are quite different from the one which you see often in the market. So I'm not going to talk about all these concerns. You are probably aware of all these concerns, but I will tell you that when we look to the single topmost problem facing humanity for the next 50 years, sustainable energy is the number one problem. Drinking water is the number two problem. There are many problems which are linked to the energy. As you know, very often the war is fought only for energy. Of course, there are various ways of energy, but what we are talking about, an energy which is safe and sustainable and which will be abundant for the mankind to use it for the comfort and to meet the essential demands. So if we look to the energy, sun is the abundant source of energy and existence of mankind. We know our planet Earth evolved from sun and our life is all governed by sun. So within 1 hour, our Earth receives enough energy to meet the global demand for 1 year. So there is no shortage of energy. We have to simply look up to the sky. Sun is shining somewhere. There is no need to dig the earth to bring the fossil fuels or to still go for coal. People say, well, oil and fossil fuels are abundant. There is no shortage of fossil fuels. You can keep on burning, polluting the whole world. But one has to also see the stone age. Stone age does not end because of lack of stones. So we are intelligent human beings. We should use our mind and brain to see what is sensible. And the sensible is to use this abundant solar energy for our benefit of the society. Why this energy is important is that it is independent of any political influence. People can claim the countries, but nobody can claim sun. So it doesn't belong to any country, it doesn't belong to any political party, so it's an independent source. And when we talk about the energy, electricity is the most important part which you need for your comfort. Imagine there is no electricity. Probably I will not be giving this presentation and you will not be having this fan running overhead and this light will be not even shining. So electricity is one of the most expensive also form of energy which we need. Solar cell is a device which directly converts light into electricity. There are many devices which convert light into something else, and from something else you can convert into electricity. But sun rays can be used to heat, and that will be the talk which you will hear after me. And another is a solar cell device which converts directly into electricity. So we are talking about this device, which is solar cell, and I would be speaking about first giving a progress in the field of photovoltaics, which is also called solar module technology, and then thin film photovoltaics, and then I will specifically focus on a very interesting material, copper indium gallium selenide, which is abbreviated as CIGS, in the form of thin film solar cells, and what are the key issues, world record efficiencies, and flexible solar cells, and then I will go about how this new and innovative technology is getting transferred on industrial manufacturing, and then I would conclude my talk. So what is a solar cell? As I said, solar cell is a device which converts light into electricity. It is a device made with a semiconductor of two different type of conductivities, P and N type, and it has two electrodes. So what you see is a solar cell basic schematic structure, and when this stacked semiconductor device is exposed to the light, a part of light is reflected, and the part of light which goes into the device material, it is absorbed. It creates electron-hole pairs. Electrons are negative charges, holes are positive, and these charges get separated and they move in opposite directions. So electricity is nothing but flow of electrons in a particular direction, and we have the so-called solar electricity. So this is how the solar cell works. You have a device you expose to the light, it creates electron-hole pairs which get separated because of the internal field, and then you have your solar electricity. So the most popular and well-established technology is based on silicon wafers. This is what you see. So one silicon wafer solar cell is like one battery. It gives you roughly about 600 millivolts or 0.6 volt, and you can connect them in series to get to higher voltage and also to have some current. So this is called a solar module, and you might have seen them installed many places. So what we talk very often is the efficiency, and just to give you an efficiency, that means when there is a very nice sunlight like today, it will have 1 kilowatt per square meter of solar irradiation. So if we have 15% efficiency, and when we have 1 square meter of module, it means we will have 150 watt. So this is just to give you the relevance of efficiency. When we want to use it for practical applications, then we have to talk about the cost, and the cost is given either dollar per watt or euro per watt or rupees per watt. And when we are talking about the electricity price, then we are talking about the price per kilowatt hour, which is also called 1 unit. Here in India, it might be maybe 4 or 10 or 15 rupees per unit. And so when you pay your electricity bill, you normally pay for kilowatt hours which you spend. So all the solar modules which you see can be categorized in 3 types of installations. One is utility scale. That means very large volume, some megawatt or tens of megawatts. Basically, these solar modules are installed in open field. So these are called ground mount systems. So these are very high volume capacity solar module installations. Then they can also be applied on the rooftops of residential building, industrial buildings, and commercial buildings. So they are called photovoltaics applied on buildings. Then there is another category where you use photovoltaic integrated elements. So the roof or the facade, the wall itself is integrated with solar module. So that is called BIPV. So in India, you see solar module installations are booming, and they are mostly on ground mount utility scale. The building related applications are still not that much popular or not that much in a strong volume yet. So when it comes to about the cost of solar electricity, this is one example. As you know, in Dubai, they have abundance of oil. So one would wonder why Dubai should go for solar electricity. They have oil, but they are thinking for future. Oil will end, and it is it creates pollution. So this is the cheapest bid which has been made of 3 cents, 3 American cents. I think $1 is roughly about 61 rupees, so you can calculate. So this price of electricity in Dubai is cheaper than the fossil fuel. So it means solar electricity, even in Dubai, which is full of oil, can be very competitive. This was in 2016, and within in the beginning of 2016 or middle of 2016, actually in May, within 6 months, the progress has happened that the price has gone down to even $1.8 per kilowatt hour. And that's not in Dubai, but in Denmark, Germany, where there is not so much sunshine compared to India or even like Dubai. So it means solar photovoltaic technology is getting very cost competitive on a global scale in a conditions where there is not even abundance of very high solar insolation. So when people say, well, whether this technology will work or not, these are the examples that this question on working of the cost-effective, clean, sustainable technology is no more there. The solutions are already there. Now we have to see how we implement them and how we use them for various applications. So in the field of photovoltaics, there are many materials, and these are called different technologies. So one is, which I mentioned about silicon wafer-based technology. This is the most abundant technology. Almost 93% of the market share is taken by silicon wafer-based technologies. And then there are some other new technologies based on thin films and some other new materials, which I will be talking about, that how they are useful and what potentials they have. At AMPA, in our research lab, we work on cadmium telluride, CIGS, castorides, perovskites, thin film tandem solar cells. So our research group of about 35 people are involved in various technologies, but we are focusing today's talk mostly on CIGS. So when we look to the different generations of technology, the first generation of technology, which is about 58 or 59-year-old technology, is based on silicon wafers. It is like single pieces, they are put together. They have been very successful. 93% of the market share is based on silicon wafer, but they have certain limitations, and I'll explain those limitations. That's why we are looking for new materials or innovative concepts. The costs of silicon wafer-based modules have already gone down, and there is limited opportunity to still further reduce the cost. The second generation of technologies are based on thin films. These are very thin coatings, less than the human hair thickness. Human hair thickness is about 50 microns, so we are talking about 1/10 of human hair thickness, which is applied on glass or metal or polymer film. And this is called thin film technology. And when you see some of the TVs, for example, or the glasses which are colored, these are based on thin film coatings. Then if you replace glass with foils, then you have some additional advantages that you can have thin film flexible solar cells, and my talk will be focusing on this type of technology. And then there are some new concepts which are based on organic materials, and I believe they are still far away to reach to the commercialization. These are some of the typical efficiencies of single crystal, multi-crystalline, and thin films. So you see that typically thin film modules are somewhat lower in efficiency, but there is a good reason to work on that. So the efficiency difference of thin film is roughly about 14 to 16% compared to multi-crystalline silicon, which is 16 to 18%. So roughly about 2 to 3% efficiency gap. So why one should work or think of thin film solar modules? First of all, in case of crystalline silicon wafers, one requires roughly about 200 micron thick material because it has a very low absorption coefficient. When we use thin film materials, they have very high absorption coefficient. So roughly 1 or 2 micron material, almost 100 times thinner material, is adequate to absorb all the light which we want to convert into electricity. Then one can have these coatings on glass or on steel or polymer films, and one can make monolithic interconnect modules, and I'll show you what it means. Basically, it looks a very nice, elegant, and fast way of interconnecting different type of solar cells. It has a potential for low-cost manufacturing, lower than silicon wafer-based technology, because it takes very small amount of energy to produce these modules. And also it opens various applications opportunities which are difficult with the traditional silicon wafer-based modules. So what I mentioned was an advantage of thin film, and most important is the energy payback time. Of course, price is important, but you know, sometimes if your daddy is very rich and he can give you subsidy and support, like solar modules made in China are cheaper than anywhere else because the Chinese government gives a strong subsidy. Somebody can sell at less than the production cost. But what is important, fact is actually the cost is the energy. So what is the energy payback time? And that's what you see here. The energy payback time of cadmium telluride or CIGS thin film solar modules are significantly lower. They are typically 1.5 up to 2 years compared to monocrystalline or silicon, multicrystalline silicon, which is typically about 2 to 3 years when the efficiencies were still low. So what we are comparing about 15% single crystal silicon versus about 11 or 12% cadmium telluride. So despite lower efficiency of thin film solar modules, they have they have shorter energy payback time because they take less energy to produce. It takes a lot of energy to purify silicon from sand to make an electronic quality silicon. So this is what is about the pricing. So when you see the dark blue curve, that is how the price of silicon has come down to now about $45 per watt, when the factories are about 100 gigawatt cumulative production. In case of thin film, even at a smaller production of about 10 gigawatt, you have a significantly lower cost. So you don't have to invest very high amount of big factories to reach to the cost competitive level. So this is yet another advantage of thin film technology. And also, this is a very busy slide, but the message which I want to give you in terms of the record efficiencies, with thin film polycrystalline silicon, the efficiencies of more than 22% have been achieved, which is higher than multicrystalline silicon or almost comparable to multicrystalline silicon wafer, which is comparable of area in the research lab. So why we want to work on CIGS thin films is, I will cover simply the key points because it has a high absorption coefficient, and what you see is that the device structure on the left is roughly about 3 to 4 micron. So it's a 1/10 of human hair. We have 4 coatings applied on large area, and it can give you very low energy payback time. It can be as efficient as multicrystalline silicon. This has been shown in the research lab, and it will reach to significantly lower production cost of electricity below 5 euro cents per kilowatt hour, and it will have a significant possibility to give you CO2 footprint reduction. What we are talking about, technologies which will help to reduce the carbon emission. And this type of technology have very low CO2 footprint. So this is yet another advantage of thin film technology. So they are of course innovative. They look very elegant, black, blue, dark blue. So these are the colors which architect like. So what you see is buildings which are used with CIGS solar modules produced from companies Solibro or Mans, and also you see ground mounted installation and also an example of flexible solar modules. There is one successful company called Solar Frontier. It is in Japan, and it is a very quite profitable company, and they have producing a gigawatt solar modules. And when we now compare the traditional solar modules are either based on silicon wafer or thin films on glass. They are heavy and they are rigid. Actually, silicon wafers are very fragile. So if you hold them, you can literally break them like this. So they need very special packaging and very good care until you make the modules out of that. And if you replace the glass with foil, then you have the possibility of making flexible solar module. So if I take the traditional solar module, which is crystalline silicon or glass, 1 square meter will weigh roughly about anything from 12 up to 20 kilogram. It's quite heavy. Sometimes for one person it is difficult to hold. And here what you see is a 4-year daughter of my secretary. She is able to lift this solar module. So it's very lightweight. So this is one very distinct advantage of flexible lightweight solar module, that it is very lightweight and it's flexible and it can be produced with roll-to-roll manufacturing. So these are some of the other summary points which I have given. It's not only about the module weight, flexibility, but imagine if you have to transport a solar module, I mean 100, let's say 1 megawatt, you will need at least maybe 5 or 6 such type of tents to transport. But if you have a roller type of carpet, you can transport solar modules just like easily in one big lorry or in one car even. And that means you have additional advantages to reduce the cost of transportation and installation. So these are some of the other advantages in addition to what I mentioned before. Another yet advantage is related to the manufacturing, and it is called roll-to-roll manufacturing. Roll-to-roll manufacturing means you take a roll of plastic or metal sheet, which is like a roll of cloth, and you unroll it and you do the coating. How cheap it can become. I'm giving you an example. When you buy potato chips packet, you buy, chips packet which has potatoes and some other chips. It's nothing, it's plastic which has a coating of some metal and some oxides to protect against moisture. These coatings are done on rolls which are 5 meter or 8 meter wide rolls and moving with very high speed. So these are very cheap. You eat the potato chip packet and you throw them in the basket, dustbin. They are so cheap. So the idea is, can we transform this type of manufacturing for solar modules? It's going to be very challenging. It's like climbing the Mount Everest, but sometimes you have to make an attempt. And in academics, we are in the university, we know you make experiments, you can fall, fail, but eventually you succeed. You keep on trying, and then you get to very ambitious type of concepts. So this is the roll-to-roll manufacturing, which is very innovative, and that's what we are trying to do with the company Fleesum, which I established with my PhD students, and one of our investors are actually Tata Group company from India. So this is the research type of solar cell, and here what I'm showing you, a world record efficiency solar cell, which is 20.4% achieved, and this is independently certified efficiency measured from Fraunhofer Institute, developed in our research lab. What you see on the right side is actually a solar module. These are monolithically connected solar modules, so different solar cells are connected in series. So they are about 17% modules. So these efficiencies are as high as multicrystalline silicon. So in our company Fleesum, we have developed this whole manufacturing machine and plant. Coming from an academic environment, and I would really like to encourage the young students, don't get afraid of. When we did our research, it was a solar cell made on a fingertip size. This was. And coming from the research labs, we are not equipment manufacturers. But we said, okay, my PhD student, we said, okay, we are not going to buy these commercial machines which do not work for these technologies. It will require about 100 millions. You can calculate how many 1,000 crores I'm talking about, 1,000 crores rupees. We said, let's do it step by step. We will make our own machines. And these PhD students, they were very courageous. We said, no matter, we will fail, fine, it's okay, we will try. If we will fail once, we will learn, and then we will tell that, yeah, we tried, we failed, maybe we can do it better. If our effort is sincere, somebody is going to appreciate our failure. So take courage, take your courage, go with your conviction, Don't go for simple things that, yeah, I can buy from here and I have to be afraid of that I will fail, what others will think. No, when you make a very courageous step with all your sincerity, even if you fail, provided you are able to explain why did you fail and what did you learn, I'm telling you the world is going to appreciate, and that's what happened with our investors in Tata. Our research group is in Switzerland, and here is a company from India who understood what is the innovation in this technology. Despite all the risks, they joined our Swiss investors and they have invested during the last 10 years continuously to translate from this research lab to a large industrial production of solar modules, which I'm going to show you that this is like a plastic foil which is sandwiched between two sheets. One is on the front and another is on the rear to protect against environmental and mechanical conditions. And so then I'm skipping, I'm not getting into all the details, but basically we have many process steps, and we have a factory in Zurich which won almost all the awards which any company can win in Switzerland. And in 2016, Swiss ambassador in Delhi also awarded the company. This was very prestigious award actually. So this is an example of this flexible solar module I'm talking about. You might not have seen it. So you see how lightweight this is. This is about 3 meters long and about half a meter wide solar module. It's very lightweight. I have an example here. So I, of course, because of the flight, I cannot bring the large one, but this is how the solar module looks like. So this is a flexible, lightweight solar module. This is smaller in depth, in the width, but you can have as long as 3 meters or 6 meters. When we do the processing on few hundred meters, 200 or 300 meter long roll, which is 1 meter wide. So I'm having a small size sample. After my talk, I'll be happy to show you this type of solar modules. So you can literally keep your solar producing device in your backpack or wherever you want to use them for application, you can use them. Another example on very small application is this one. This is a mobile phone charger. It's a flexible solar module which is laminated on the case, and this is a connector. So literally you have power in your pocket. So when you want to charge your mobile phone, you don't have to look for power point. You can simply plug it in, put it in the sunlight. Half an hour will give you more than 1 hour of talk time. It's not only for mobile phones, but when you need higher voltage or wattage, you can have many such small solar modules. And you know, this is like my wallet. I'm taking from my pocket. So here you have higher power modules. So with this or somewhat larger, you can charge other electronic gadgets. These type of applications are absolutely not possible with traditional solar modules. You cannot carry this type of weight in your pocket. You cannot carry them in a rollable manner. So that's where when I titled my talk, we are talking about innovative and new technology. I'm talking about something which is for future and which is quite different. So this type of solar modules which I showed, they can be laminated on steel and they can be applied on the roofs. This is actually a Swiss village where they are using some metal sheets as a roof. So this metal sheet which you see, this doesn't have a solar module. It has no functionality, that is simply it provides you a protection against the roof. But when you are able to have a solar module integrated, then it helps to produce solar electricity, and it also helps to reduce the CO2 footprint of the building. In future, we are talking about CO2 footprint of reduction. So these are some of the examples I'm talking about, and what you see that we have here in India, you know, the roofs of steel or metal, they are very lightweight roofs. If you want to install traditional solar modules, many of the roofs will not be able to withstand 10-20 kilograms per square meter of weight. So when you have these lightweight solar modules, you have the possibility to simply put them on the buildings. On the other side, what you see on the left lower part is a very beautiful black aesthetics. Architects like them. So these are some of the examples which I showed. So there are many possibilities, not only for ground mount, for buildings, but also for space applications. If you want to launch a satellite, 1 kilo launching cost takes about $50,000 to $60,000 for geostationary. So if you have a lightweight, you have additional advantages of solar modules. So these are some of the advantages which one can imagine. And at this point, I would like to stop with one comment that it's not that we have reached to the efficiency limit of the solar cells. We can go beyond 20%, and actually in our research group we developed some know-how, and we are working towards 25% solar modules, and then we are targeting towards 30% solar efficiencies, but these are from the research type of devices. So at this point I would like to stop, and I would be happy to answer any questions you might have.